Hey guys, what we're doing today is we are just having a look at the third index law, which is basically raising something that is already raised to a power to another power. So, for example, the general rule is a to the power of m to the power of n is equal to a to the power of m times n. Alright? So that's just saying that if you raise something to a power and it's already raised to a power, you just multiply those two powers together. So we'll do an example. If I had 8 to the power of 2 raised to the power of 3, right? That is 8 to the power of 2 times 3. And we can sort of explore that and see why that works, if you like. So essentially we're saying that this 8 to the power of 2 is just 8 times 8. Right? That's what we're saying. That's 8 times 8. My camera's gone blurry again. Come on, focus. Yeah, okay. There we go. So, we have 8 times 8 to the power of 3. Then, if I were to write out this to the power of 3 the long way, I would write 8 times 8. That's 1. Times 8 times 8, which is 2. Times 8 times 8, which is 3. 3 sets of 8 times 8. And if you count all them up, you're going to get 8 to the power of 1, 2, 3, 4, 5, 6. If you do it this way, you get 8 to the power of 2 times 3, which is also 8 to the power of 6. That's just an example as to why that works and where that rule comes from. So I'll do a couple more examples. So if we had 2 to the power of 7 raised to the power of 6, I'm not going to write this one out because it's going to be way too big. That equals t to the power of 7 times 6, which equals t to the power of 42. And you can see why I didn't want to have to write all that out. Alright, and now I'll do an example from today's exercise, just because it's a little bit harder. Let's say we'll do 2d to the power of 7 to the power of 3 times 3d to the power of 2 to the power of 3. Now this is combining, or will be combining, a couple of index laws. So firstly, I'm going to get rid of these brackets, like you do with BODMAS. Let's go back into focus, please. Okay. So one thing to take note of is that you have to treat each value in the brackets separately, right? So if this is raised to the power of 3, it means this 2 is raised to the power of 3, and so is this d to the power of 7. And as a general rule, if there is no index law, if there is no power next to it, it just means to the power of 1. It means there's only one of them. Alright, so I'm just going to fill in those two ones to make it easier for when we work it out, but you don't have to. Okay, so that equals 2 to the power of 1 times 3, and d to the power of 7 times 3, multiplied by 3 to the power of 1 times 3 times d to the power of 2 times 3. Right? So I'll quickly work all these out. So it's 2 to the power of 3, d to the power of 21 times 3 to the power of 3 times d to the power of 6. Right? But I can simplify this even further because now I'm multiplying these across, and if you remember from the last index law, that means that if you have the same base, like I do with those d's, that you can add them. But let's turn these two numbers into actual numbers, I guess. So 2 to the power 3 is 2 times 2 times 2, which is 8. So 8 times d to the power of 21 times 3 to the power of 3 is 3 times 3 times 3, which is 27. That's 27 d to the power of 6. Alright. So if I want to do this sum now, I just got to do 8 times 27. So okay, what's 8 times 27? And I'm trying to do this off the top of my head, so if I get it wrong, don't make fun of me. I think it's 202. 206. 216. Okay, 216. So 216, and then remember, if going back to index law 1, if our bases are the same, we just add those two powers together. So d to the power of 21 plus 6, which gives me 216 d to the power of 27. And that's it. Alright, so that last example was a little bit hairy, but you can see how that links together. My best advice that I can give everybody is to write out every step. Don't skip steps. That's where you make mistakes. So yeah, hopefully that helped. Enjoy. Thanks, guys.